Good afternoon, everyone. Welcome back to another episode of Dojo Live. Today is Tuesday, April 19th, 2022. This is Tulio Siragusa, broadcasting from Southern California. And joining me today is Kim Lantis in Hermosillo, Mexico. Hi, Kim. Welcome back.
Hey, Tulio.
And from Salt Lake City, Utah, we have our guest, who is Troy Harvey, co-founder and CEO at PassiveLogic. Welcome to the show, Troy. Great to have you.
Yeah, thanks for inviting me today. It's fun
Today,
to be on.
Yeah, let's have some fun. Today we're going to
pleasure.
talk about smart cities, smart buildings, automation. But before we dig into that and see what we can learn, see how it's evolving today, let's get to know our guests and let's get to know your company a little bit. If you could please tell us a little bit about you, Troy. We'd love to get to know you. Once again, welcome to the show.
Yeah, thanks. Well, I'm a native product designer. That's how I started my career, and I then ended up somewhat accidentally in the building space about 15 years ago. And that was because I started doing some physics simulation of buildings to see how buildings behaved. And then I ended up getting hired by an architect that I originally went to help me design a building. And he said, "Hey, how about you help me design a building?" And that just really unfolded into an unexpected career path around buildings, high performance buildings, green buildings. And in that process, really started to ask this question of why don't buildings work? And that's what really led to PassiveLogic.
Interesting.
Cool.
I'm very intrigued by this idea of how buildings behave. I'm going to ask you about that later on. It's an interesting concept.
All right. So something gave birth to PassiveLogic. What, you kind of hinted a little bit to it, but maybe you can give us a little bit of history and what is it that you guys do today?
Yeah. So the history behind it is as we were designing this previous company of mine, these high performance buildings. So around the 2005, there was this big emergence of the green building movement, or more broadly, the high performance buildings. How do we make better buildings, more efficient buildings? And part of that was what most people might be familiar with, like the LEED building approach, getting LEED gold status or LEED platinum status in a building as a ranking of how quality was your building from an environmental and health standpoint. And what we started to observe was that the more energy efficient buildings became, and the higher the LEED status that a building tried to obtain, the less likely it was to actually attain those goals. So why? And the why became, it turns out that what people hadn't really thought about in buildings is buildings are the world's most complex systems. And as you tried to make them more and more sophisticated, you made them more complex and therefore less likely to ever be able to control them. And so I think what really emerged out of that is we started to think about buildings with robotics theory and say, well, look at a building. It is really a giant stationary robot. And in robotics theory, you think about degrees of freedom. Let's say like you have a robotic arm that's doing factory work. It has, it has a wrist and it has a hand and it has an elbow. And each one of those is what we call a degree of freedom. And so in a robotic arm that's doing factory work, you might have 6 degrees of freedom. Well, it turns out when you look at the average commercial building that's in any major metropolitan city, not the big ones, just like a really average one, you very easily have hundreds to thousands of sensors and hundreds to thousands of control points. So all of a sudden you have thousands of degrees of freedom. And when you compare it to any other use case, like autonomous vehicles, if I look at a Tesla might have a few dozen sensors. It has cameras, it has ultrasonic sensors, it has a variety of sensors to engage in its environment, understand what's going on. And it has 3 controllable items, right? It can steer, it can brake, and it can accelerate. But we look at a very large building in the building space, and we have projects that are 500,000 input and output in really large buildings, right? And so these are the most complex robots or systems that people make. And the disconnect between the complexity and the solutions is the emergence of all these problems that we see in buildings.
I love the way you guys think. I really do. I I can see how you hold this context around the view of what a building is, and this stationary robot. I love it. Okay, let's see what we can learn today, because it sounds like we're going to learn a lot. So Kim, if you could introduce the topic and what is it that we're going to discuss, let's kick it off.
For sure. Thank you again for being with us today, Troy. The topic as chosen by you is generalized autonomy and automation for buildings, specifically autonomous buildings enabling energy efficiency and providing the foundation for smart cities. So you kind of already answered my question of building behavior, right? Being this complex robot in a way. My question for you is really the crux of what you chose to talk about today. And that's energy efficiency, the foundation for smart cities. And my first question is, why should builders and people in general care? Why is this important for us?
Yeah, well, I think there's a spectrum, right? On one end of the spectrum, we fundamentally have to solve climate issues. But on the other end of the spectrum, why do we care? Well, it turns out every building, this is where we start with buildings, that no matter what kind of building you're building, whether it's industrial or commercial or residential, we always have to start with control somehow, right? And so it's always there. And that control system may be as simple in a residence as a few thermostats, but understand that behind the scenes, even in that simple residence, that thermostat's telling some other piece of equipment that has a bunch of control inside of it how to do something more complicated, right? And so when you get into commercial systems start to look like all the pieces and parts of what's already put in a box in a residential system, and the individual installer or engineer is having to assemble that engine for that building as this sort of unique one-off project. So somehow we have to control buildings in the first place. And let's start with, how do we make that not suck, right? Like today, that's the fundamental challenge, is everybody has to control, but the results aren't very good.
All right. Well, thank you. Thank you very much. And then shifting into this autonomy, right? Automation. What does that mean specifically for buildings?
Yeah, so let's talk about the autonomous vehicles context, because I think we've spent last 10 years in tech culture thinking about autonomous vehicles. If you wind back 10 to 15 years ago, people didn't know what you were talking about then either, about vehicles. So use that context and then start talking about, how does it play within the buildings world? So in a vehicle, when you have an autonomous vehicle, that vehicle is one of autonomy within space. So you have a vehicle that starts at point A. It's going to navigate through a map to get to point B. And it's going to do it in the most efficient way. It's going to not hit anything along that path. That's the goals. Cross fingers. In buildings, we don't move in space in buildings. We move in time. And it turns out the problem set is the same, only we're looking down a tunnel of time, and we're going from point A in time to point B in time. And we look down that tunnel of time and we could say, oh, there's millions of different control paths I could take between A to B. And it's a little bit more sophisticated than vehicles, because in vehicles, you're navigating one vehicle through a map. In buildings, we have all these systems. So we're navigating this whole fleet of systems, all in coordination: heating, cooling, ventilation, occupancy systems, energy systems, maybe energy storage. Maybe there's some internal logistics systems or internal
water
or manufacturing systems that you're trying to coordinate all together, right? So at the end of the day, the thing that's interesting is they both come down to AI-driven route finding. How do you find the best route?
Okay.
So with all these controls, usually you have some intention behind it, right? Is there some underlying goal that you're trying to accomplish?
That's right.
Energy savings, or just better efficient use of whatever? What are some of those things that contextually you're trying to achieve in smart buildings like this?
So I think that's a really interesting point to move from the question you had, Kim, which is, what is generalized autonomy? So if I am Tesla or I'm Aurora or Cruise, one of these companies that's doing vehicles, you have hundreds of PhDs who are all training an autonomous platform to be one thing, to drive a car. And that Tesla is never going to be a helicopter. It's never going to be an airplane. It's just going to be a Tesla. In fact, it's not going to be any other car. It will just be that car, right? And so to your question, the challenge in all the other use cases beyond vehicles is you need something more than an autonomous platform. You need generalized autonomy to describe that every one of these other kinds of projects besides cars, ever since Ford, cars have been a conveyor belt process of mass manufacturing of the same car over and over and over again. But almost everything else, like buildings, they're all one-offs, right? There's no two buildings that are the same architecture, systems, equipment, goals, and values. And so you have to have something that does more than how do I control it autonomously? You have to have how do I assess the environment and what its needs are autonomously, and what are the goals at any given moment? And there might be multiple goals. And then how do I inspect or introspect myself to adjust to the changing goals and the changing environment? Where maybe right now in Sonora, it's well, not cool because it's still not, but it will get
definitely
hotter.
Not. Yeah, yes.
Your system could say, oh, I know that it's going to get hotter, and perhaps maybe electricity is cheaper in the middle of the night. Maybe I can pre-cool the mass of the building while electricity is cheaper, and then make sure that I can kind of cruise through that like 3 o'clock in the afternoon super hot period without drawing down when pricing peaks. For example, of one of thousands of different scenarios that might occur in a building's juggling of different values.
Right. Or here, like the automating the shades, the blinds to go down at a certain time of day,
Right.
or open, or whatever it might be. My question is, I see how tech is involved in that, but do we have to take a step back to the design itself? Like where's the optimum place for this technology to come into play? I mean, obviously where we are today, buildings exist. People want to maybe convert existing buildings into smart buildings versus building it from the very start as an autonomous unit. So how much thought needs to go into things like positioning, where the sun is, where it isn't, building materials, and those types of things to make the best autonomous building?
Yes, that's super a great question, because I think there's several paths you can take, right? And no matter whether you're saying I've got a lot of existing buildings in the world and we need to make those better. So how do we make a system that can understand the context of an existing building and make a digital workflow so that the platform itself is doing a lot of the work for us, and not just in the automation, but in designing its own systems, helping through the process of the values assessment. But also to maybe what you're alluding to, Kim, is that if you now have autonomous platforms for buildings, it now goes back to where my career started in buildings, where architects were asking these questions of now what's possible. And it unfortunately in the buildings world today, a lot of what's possible gets what we call value engineered before it actually is built in the ground, because what's possible may not be attainable in reality, and we don't see that actually happening.
So it's like in the tech world, this is got the UI UX team versus the development team, and they're like, that's nice, but can we build it?
Right. And that's really, in fact, that whole process is how we start as a company. We said, well, what would be that workflow? What does everybody in the industry of buildings want to do? Okay, I don't want to program buildings. I just want to draw what my building is, and then drag and drop sensors and IoT devices into that drawing. And I want to draw what my systems are, what those energy systems, HVAC systems, occupancy systems, and take programming out of the loop, and then have that then generatively design my control system and automatedly train the control system, and then start controlling the building. Well, how do you make that possible? So we actually did start with our UI UX, and then we spent several years making new technology to make that UI UX possible. And we ended up in a new form of AI that we call deep physics, that we can get nerdy about if you'd like.
Yeah, speak nerdy to us. Go geek.
Just kind of, blow this out a little bit if we could. So obviously there's a lot of design thinking behind the thought process of the intention or the goal of that building. I mean, it all's designed to serve people, right? Without people, there'd be no need for the building, right? I mean, all the controls and all the automation isn't for its own sake. It's because it has to serve the needs of people showing up there, living there, working there, what have you, right?
Right.
So there are some key resources that buildings utilize a lot of: energy, water, what have you. And so today, a lot of the controls and a lot of the smarts are built into this, let's call the closed garden, the building itself. But is there also thinking about how that particular building will play in a grid of other smart buildings? Yeah. I.e., for example, maybe I have solar panels in my building and I have excess energy and I could actually sell it to my neighbor down the street, but it could be created in such a way where it's autonomously bartered or paid for or what have you. Is that where it's going ultimately, and are builders thinking about how to plug into that grid in the future, or is it predominantly now still a closed garden mindset? What's your thoughts?
Yeah, so I think there's like at least 3 steps in there. So, starting from, what are the goals? What are the goals of building? And fundamentally, like you suggested, most buildings are about people. Some buildings are about maybe a manufacturing process or a logistics process. One thing that's really interesting, if we think about the big players in buildings today, so Siemens, Schneider Electric, Honeywell, and Johnson Controls, those are the 4 big players. They all had their start in the mercury switch thermostat from the 1800s. And that was the first kind of controls we had of like, how do we make it people-centric? Well, what's interesting is today, that's still what you have. It's that mercury switch thermostat, I think, was first invented, like 1857. And even if you have like a Nest, that's just a digital emulation of a mercury switch thermostat with its own website. And to your point, that's not actually how humans experience comfort. So air temperature, which is what thermostats measure, is one of about 8 variables that measure comfort. And so it's about 20% total information when you look at like the weighting of that information you need to describe comfort. So this sort of situation happens all the time. We'll go back to our Sonoran Desert example. You could have air conditioning, keeping it at 72 degrees Fahrenheit. Maybe you want to think in Celsius. If I do this right, maybe it's like 21 degrees Celsius. And
that's a little cold. Maybe 23, 24.
23, 24. Okay. And your temperature, like your thermostat's staying the same temperature all day long, but you go from hot to cold to hot. Well, what happened there? Well, it may be that the sun came in the windows and changed the radiant temperature. The air temperature stayed the same, but your radiant temperature went up and your body experienced a different kind of comfort, right? So the physiology of comfort, the physics of comfort is well known, but your current controls don't know anything about humans and physics, so they can't accomplish what your actual goals are as a user. So there's all of these use cases in buildings where what are the goals? Right? As opposed to sort of the implementation details of like, okay, it's 72 degrees. You don't really care about that. What you care about is, am I comfortable? Right. So that's on the first side of your question, is like, how do we make buildings do what they're supposed to do? Does that make sense as a starting place?
It does. And we're getting back to the physics of this. Right.
Yeah. And so maybe we'll do like a little deep dive on the physics, and then we'll come back up and talk about the building, sort of smart grid. How do we make smart cities work?
Perfect.
So let's talk a bit about AI and what's happened in the last few years in AI, and what's awesome about it and what's missing about it. So the big shift in AI in the last 10 years is deep learning. Now, what's funny is there was what we called the AI winter, and it emerged in like 1986, and you weren't allowed to use the word AI. It was like talking cold fusion. So nobody used that word until about 5 years ago. It was all of a sudden acceptable to use it again. In the meantime, we just called it ML. machine learning.
1986, and this has something to do with like the Terminator franchise, perhaps. I don't know.
You know, it was.
Did it make it go dark?
Well, there was a lot of hope around AI technologies in the 80s, and then just the investment market dropped out. And that was because of that we were not meeting the goals of the promise of what AI could do. So why was that? And then what happened in 2012 with deep learning? So I'll put this into perspective, and hopefully we'll do a good job of making it accessible. So what is deep learning? Is it neural nets? That's what most people tell me when I interview them. I say, what's deep learning? They'll say neural nets. But neural nets have been around since the 50s. So it's not neural nets. And then people say, well, it's about GPUs. GPUs are much faster. It's like, well, but we could have clustered computers together in the 90s too. Like that's not the answer. So the answer is a thing called differentiable programming. And that's what made deep learning come about. And so what is differentiable programming? For the history of computers have always run forwards. You have a function that takes inputs and gives you outputs. But there's a lot of problems in the world that you already have the outputs. Like I know that you need to be comfortable in what comfort is, but I don't know that's the answer. The question is, or what is the input is, how would I do that to the building? And that is what we think of as reversible computing, to be able to turn the problem around and get the reverse to that question to answer.
Which is like we do in physics, right?
Just like we do in physics. But the problem is to do it in a generalized way means that you'd have to hand reverse all of the problems. And that would take all the physicists all the time to ever solve, right? So along comes differentiable programming, which interestingly enough has been discovered and forgotten at least 5 times and stuck with deep learning, which had the problem of neural nets had been around since, the 50s. In the early 80s, when they had all this promise, and the ground fell out below AI was because we couldn't make big enough neural nets to do anything interesting. And so the classic cat problem, can you recognize a picture of cats and have it say that's a cat? It took many, hundreds of thousands to maybe millions of neurons to do that. And you couldn't solve that problem with the biggest computer for hundreds of thousands of years worth of compute time, because you have to figure out tuning and tweaking millions of little inputs to get it to recognize cat, no cat. But if you could reverse that problem, you have one input, you have one output, right? That is cat, no cat. And you say cat, no cat, and get a million outputs. All of a sudden you could make something that took hundreds of thousands of years to solve, and you could solve it in days or hours. So that's actually what is driving deep learning, is not neural nets at all, but differentiable programming, the ability to turn things around.
Well, I mean, we've also had to wait for technology to catch up, right? The internet commercially wasn't really available till like 92, 93, and then computing power was just way behind. So I can see how interesting that AI has been ready for several decades, but the technology has been the limitation, and that seems to be slowly and actually quickly going away now with quantum computing and other technologies and innovations that are being discovered. Let's talk a little bit as we come to the end, how PassiveLogic plays into the mix of all this. Love to understand a little bit about what is of this entire massive equation. What are you guys solving? What is it that you guys are working on?
So we essentially take the ending place of deep learning, of differentiable programming, and we generalize it to any kind of problem, not just neural nets, any kind of problem. And we build on top of that physics, and we sort of merge together physics and neural nets into what if every neuron didn't just have some generic function, but had a little bit of physics that represented some concept within a building or a system and equipment, maybe your human comfort. So with that, we're able to solve this broader set of problems, and we're building our own compilers here and our own AI frameworks that run on top of those compilers, so that we can enable these bigger sets of challenges that not just in buildings, but when we talk about generalized autonomy, we mean generalized autonomy. What if you could, in a short period of time, describe whatever system you want and then be able to generate its own control autonomous platform in just a matter of minutes of definition. So that's the underlying enablement for this building space. To get to that smart city piece, so in order to have smart cities, you have to start with something else. You have to have smart buildings, right? And so you can't, we love talking about smart cities, but you can't have smart cities unless you have smart buildings. We like to talk about smart buildings, but nobody's watching this has ever seen a smart building. So what you really need at the end of the day, as you brought up, like you could have solar panels on your roof, right? So what happens when your building is producing excess power? Unless you have a smart building that can negotiate in real time, hey, does the power company want this? They're going to offer me 10 cents a kilowatt hour. The LEED Platinum building down the street might offer me 16 cents a kilowatt hour. Or maybe I can compute that I could use that energy to build up heat and store it in hot water, because I know in 3 hours I'm going to have a bunch of occupancy demand for hot water. Maybe that's worth to me 20 cents a kilowatt hour. And I'm going to use in real time, be able to shuffle these things around, right? Or have what becomes more of a peer-to-peer energy market instead of this very much, you've got the power company and then all of the customers, right? And not only do we need that as we shift our energy economy within the developed world, but in the developing world, generally speaking, that's the world they already live in a peer-to-peer energy economy. And we need to start working in that context to really get more resiliency in the grid and more diversity in the energy, networks.
I love the context that you hold around sort of looking at buildings and smart city like living organisms. That is such a game changer in frame of mind. As I mentioned before we started, I was an advisor to an AI company focused in the smart city space. If I had thought about it in those terms, it would have been such a game changer years ago, because now you're not just solving problems for an inanimate object, but something that's like a living organism, as if you need to show empathy like it's a person. Such a great context that you guys have adopted. I love it. So I just wanted to recognize that.
Yeah. And when you look at it in that perspective, going back to the reverse engineering or whatever, the possibilities, the outputs then get so much larger.
Right.
It's fantastic.
So we're coming up on time, and I'm curious to learn about the culture of PassiveLogic, because so we have audience members that are looking to learn about interesting companies. It sounds like the tech and the way you're going about it is very cool and very interesting. Tell us a little bit, like, what's the day in the life there, PassiveLogic? What kind of people tend to want to come work there? Why should they come work there? I'd love to get a little bit more into the culture, if you could.
Yeah, absolutely. I think, what really differentiates PassiveLogic in today's tech world is, I think we're in a way a throwback to when tech did big things and tech did hard things. And so our culture is definitely built around people who design product, who build new technologies. I think we're really differentiated from this world in the SaaS world, where it's been a very, I think, business driven, where people are like, hey, what's the quickest way to revenue and quickest way to get up the curve, as opposed to us is like, how do we do what needs to be done, like build a platform from the ground up that solves today's problems. And what we find on the cultural drive for people is, it turns out there's very few companies that are building things from the ground up, wholly new tech. And that brings in, whether we have guys who have come to us from Google Brain or people who come from traditional industry like Johnson Control or Honeywell, are like, hey, those guys are never going to do this in a million years. That we're really driven around, like, let's go build these fundamental pieces that change the way that we think about buildings and do it holistically as a complete system.
Love it. All right. So if you want to be a change maker, this is definitely where you want to go check out PassiveLogic. We're up on time, but it's been great speaking with you. We've learned a lot, and we encourage you to just stay with us in a few minutes as we go off the air. Kim, we have one more live show this week, right? I think we have a design thinking show Thursday morning. Is that correct? Who do we have coming up? Do you have that?
I do believe that there is that design thinking show. You kind of caught me with my pants down here, Tulio. I cannot recall the name of the guest.
I happen to know him personally, so I'm looking forward to it. We're going to have
Chad Engelou or Engelau. How do you pronounce his last name since you know him?
Breezy.
Oh, I was confusing that with a different. I'm just going to shut up.
Yeah, no, he's the CEO of Now or X, which is basically pharmacy on the road, on-demand pharmaceutical services or products on the road. So looking forward to speaking with him, seeing how he's disrupting the pharmaceutical industry in a big way and how they designed that, how they made that happen. So looking forward to that Thursday morning at 10 a.m. And then tomorrow, we don't have a live show, but we will have a restream. So just keep your eyes and ears open for 12 o'clock noon restream. There'll be something interesting out of 400 plus different interviews we've done that will take your interest. And if you ever want to check out any of the shows or just curious, you can go to dojo.live. That's the URL. It's that simple. There's a search box and you can type in a topic or keyword, anything that interests you. Chances are we've had a conversation with some CEO that's making that happen. And if we haven't, you can nominate a company that you'd like to know on the show. Thanks for being with us today. We'll see you again Thursday morning at 10 a.m.